All right, so let's go ahead and start going over this. So if we were to translate the following point A, which is at negative 3, 6, we wanted to go down 3 units and to the right 2 units, then what's going to happen here, when we move to the right by 2 units, moving to the right 2 units means that we're going to take our x value and we're going to add 2. So I'm going to take this x value, which is located at the negative 3, and we're going to add 2. And that means that A prime is now going to have an x value or an x coordinate of negative 1 for our A prime. And then for our y value, we are going down 3 units. So that means we're taking the y coordinate and subtracting 3. So we're going to do 6 minus 3, which is going to end up at a positive 3. So A prime is located at negative 1, positive 3. Okay. For problem number 2, if we have point F is at x minus 4 and y plus 2, and then it's translated 5 units left and 2 units down. So again, 5 units to the left means that we're taking our value and we're going to subtract 5. And then 4 units down means we're going to go ahead and subtract 4. So from our x coordinate, we've got a negative 4, and we're going to continue subtracting another 5 from there. So f prime is going to wind up having an x coordinate now at negative 9. And then for the y, we're going to subtract 4 away from the plus 2 that we currently have. And that means that we're going to be at, oops, sorry. Let me fix that for just a second. This is why you always want to have whiteout tape. This should be at x minus 9. X minus 9. And then for your y coordinate, it should now be at y minus 2. Y minus 2. So f prime is at x minus 9 and y minus 2. Because again, you don't know what x and y are. You have to maintain those x and y coordinate portions. Okay, and then problem 3, if x starts at 0.38 and then it translates over to x prime, which is at negative 2, positive 10, we want to know what the rule is going to be. So we're going to start at a 3. So for the x, we are starting at 3. We are adding some form of an x value or subtracting an x value to it in order to end up at negative 2. We want to know what the x value is going to be. So all we have to do is subtract 3 from both sides, and we'll find that the x translation is negative 5. So that means that we moved 5 units to the left. We moved 5 units to the left because the amount of change that went from starting at 3 and ending at negative 2 was moving backwards 5 units, or left 5 units. Then for the y portion, we started at 8, did something to the y, and we ended at a 10. So if we take 8 away from that 10, then that means that we are at y equaling a positive 2, which means that we moved up 2 units. So 2 units up. Okay, so there is our rule. We went 5 units left and 2 units up, or x minus 5 and y plus 2. Okay, any questions? All right, let's get into reflections and rotations. So for reflection, a reflection is basically just flipping an item. Okay, think about when you're looking in the mirror. If you ever have words on your shirt and you look in the mirror, can you read it? Like, is it going to show you exactly what it says correctly? No. It's backwards, isn't it? It's in a reversed order. It's because it's flipping the figure. So your mirror image is flipping it. Your cameras actually do the same thing. Back in the old cameras, before we had digital cameras, it would do the same thing. It would have a reversed image sometimes. And then when technology started to improve, then you were able to go, okay, well, what was on the right side is now currently still on the right side instead of it being flipped to the left. Okay, your phones can actually do the same thing. Your phones can actually go back to that reversed or flipped image. Your line of reflection. Your line of reflection is what you are reflecting across. And for you guys, we are primarily going to focus on just a reflection across the axes. So if we reflect across the x-axis, then that's going to just take whatever was on the top and flip it down to the bottom and vice versa. So it looks like a vertical flip. If we reflect across the y-axis, which is our up and down axis, that's going to do what's called a horizontal flip, because you're taking what was on the left side and flipping it across to the right side. Okay? Now, here's the important rules. When a reflection occurs across the x-axis, so if you have a reflection across the x-axis, your y-coordinate is the only thing that changes. Your y-coordinate now becomes the opposite. So if it was originally a positive 3, it now becomes a negative 3. Your x remains unchanged. If it was originally a negative 7, it becomes a positive 7. It just changes to its direct opposite. So let me write that down. If you had an original x, y, and then you did a reflection, so we'll highlight that in green. If we reflect across it, if we reflect across the x-axis, then the only thing that's going to change is that the y becomes the opposite. So we no longer call that negative sign a negative. We call it opposite of y. Okay, this says opposite of y, because I don't want you thinking that you always just get a negative value. Again, if your y was already a negative, it becomes the opposite of it, which is a positive. And then the same thing for if you reflect across the y-axis. If we do a reflection across our y-axis, then when you start at your original point of x, y, your x becomes the opposite. The y remains unchanged. X becomes the opposite. Y stays exactly the same. So a reflection across the x affects your y. A reflection across the y reflects your x, or changes your x. Alex, head up. Thank you. Any questions so far? All right. Can I change this over to the next page? All right, you go ahead and flip it on over to the back. All right. So we want to go ahead and reflect across the following points. So again, I'm only going to do one of them. I'm only going to do one of the points. You're going to do the other two. So for here, for point A, if I am wanting to reflect across the y-axis, I'm doing a reflection across the y-axis, then that means only x is going to become the opposite. X becomes the opposite value. So only your x value is going to be affected. So that positive 1 is now going to become a negative 1. So A prime is negative 1, 4. Go ahead and do B and C prime. All right, so B prime. Jimena, what did you get for B prime? -2 and 3. Again, all that's going to be affected is the x coordinate. What about for C prime, Valentina? +1, +1. It's just going to be the x value that is affected. That's the only thing that changes. It becomes the opposite. Alex, stand up now. No, stand up. Yep, push your chair in and just stand up. You get one chance, and if you start falling asleep in my class again, then you have to stand. All right, problem number 2. We're going to reflect across the x-axis. So again, if we are doing a reflection across the x-axis, then that means only the y-coordinate is going to have a change. Just the y is going to become the opposite. So I don't think I need to do an example of this one. I think you can do all 4 of those on your own right now. All right, K prime. Who can tell me what they got for K prime? Bridget? 2, -3. So the only thing that's affected is the y coordinate. It becomes the opposite to a -3. What about for L prime, Armando? 5, -1. Only the 1 was affected. For M prime, what did you get? Andy, what did you get for M prime? 4, 2. 4, +2, because that opposite is affected. And Maya, what did you get for N prime? 1, 1. It's just the -1 becomes its opposite. Okay, now the rule, if we're going from A to A prime, what effect happened first? Alex? It was a reflection across the x. So to go from A to A prime, it was a reflection across the x-axis. Okay, and then to go from A prime to A double prime. From A prime to A double prime, what was that? Dylan, what would that be? From A prime to A double prime, what happened? It reflects across the y-axis. So from A prime to A double prime, you're just going to reflect across the y-axis. Okay, very simple stuff. Reflections, not so bad, but again, once you have all the rules together, it can get confusing, so you want to make sure you remember those rules. The rotation, that's the one that seems to hit people the hardest. So a rotation is just turning a figure. It's when you turn it about a fixed point called your center of rotation. For you guys, we are going to primarily focus on the origin being our center of rotation. But your center of rotation could be any point off of the shape, or it could be any point on the shape, or even inside the shape. Okay, but we are going to focus on always rotating about the origin. That's our only rotation.
So, so you know when we were doing that like paper that we were creating, so there was like a question that had like the reflection into the Z. When it was turned, wouldn't that count as a rotation when they turned the Z?
Yeah, if you're turning it, because then that would be a turn within the point, like some point on Z, maybe in the center value of C. That could be a turn or a rotation in that sense. But there's also sometimes where a combination of some of your transformations can create what looks like a rotation. So, like, if we do a reflection across the X and then a reflection across the Y, that's technically a rotation of 180 degrees. So a combination of those two will create a single transformation of a rotation. So, and we'll talk about that a little bit more in detail. Okay, so first thing you guys need to make sure you understand is directions. I can't tell you how many people don't seem to remember what direction clockwise is and what direction counterclockwise is. But your clockwise direction is going to mirror the following right here. Okay, It's not even like it goes from left to right. It starts to go right, and then it goes left, and then it goes right, and then it goes left. There's not really a direction. You just have to remember when you're looking at the clock, the direction that the clock turns, that's clockwise, and then the opposite turning is going to be counterclockwise. Okay, so you need to make sure you understand your directions. What direction follows clockwise, what direction follows counterclockwise when it comes to graphing. Okay, on the next page, on the last page, that's where we're going to go ahead and start talking about the rules. Those infamous rules that I told you can be very confusing if you don't study them. You need to make sure you study them. Okay? So, I didn't type them out for you because I think the best thing to do when having to learn these rules is to write them by hand. So we're going to start with our first rotation. We've got clockwise, and for all intents and purposes, I'm just going to put CW to represent clockwise. CW is clockwise, so if I want to go clockwise 90 degrees, that is also the same exact thing as counterclockwise, so CCW 270. If I rotate clockwise 90 degrees, it'll take me to the exact same position as if I were to go counterclockwise 270 degrees. So if I start at a point of XY, then what happens, it becomes the point Y opposite of X. So remember, and I'm going to even draw an arrow here, what this means is that means opposite of X. Your original point of XY becomes Y opposite of X. So where your Y originally was, it now goes into your X position. Where your X originally was now goes into your Y position, and it becomes its opposite. Yes?
So basically, you're saying that I feel like clockwise is like 200 degrees, that counterclockwise would be 160 degrees?
Yeah. Yeah, they're the opposites. So here, let me show you an example too using a point. So if I have the point -2, +6, then when I rotate it, it becomes +6, +2. Right? The Y value comes to the front, the X value changes to an opposite and goes to the back. That's the rules for clockwise 90, counterclockwise 270. Okay, then the nice thing about clockwise 180 degrees, it's the same idea as counterclockwise 180 degrees. Okay, they are identical. So if you go ahead and start at the point XY, this becomes the opposite of X and opposite of Y. So the X and the Y stay in the same position, but they just become their opposites. Hence the reason I've told you that a double reflection across the X and then across the Y is identical to a rotation of 180 degrees. Okay, a reflection across the X would give you the opposite of Y, and the reflection across the Y gives you the opposite of X. So when you do that double reflection, it's just going to give you that rotation of 180 degrees. So let's take that same point that we had before. We had that -2 and +6. Then this becomes a +2 and a -6. Okay, and the last rule that we're going to focus on is if we were to go clockwise 270 degrees, then that's the same thing as counterclockwise 90 degrees. Starting at the point X, Y, this becomes the opposite of Y and X. Notice that these two are very similar, aren't they? Those two rules are very similar. So those are the two rules that most people tend to flip-flop and mix up. Be very careful about those. Okay? Clockwise 90 and clockwise 270 look very similar and often get confused. So you want to make sure you're making those flashcards, especially for those two rules. Okay? If we started at that same point that we talked about, -2, +6, then it becomes a -6, -2. Okay, so what I want you guys to try doing, because I already showed you an example of what those rotations look like. I want you to try problem 1, which is having you rotate 90 degrees, 180 degrees, and 270 degrees for each of those points. Actually, I'll just do point A for you, and then you do point B and point C. And then problem 2, it's counterclockwise 90 degrees, 180, and 270. And I'll do point X for you. So let's take a look here at problem number 1. If we're going to go clockwise 90 degrees, clockwise 90 degrees, I'm going to circle that in orange because that means I'm just going to do the opposite of my Y. Or sorry, I'm going to flip-flop it. I'm going to bring my Y to the front and do the opposite of my X. So I'm going to bring this Y to the front, and I'm going to take the X and put it in the back and do the opposite. So it's going to become a +3. So we get the point 1, 3. That's our rule. Our rule indicates that we're going to do Y opposite of X. If I do clockwise 180 degrees, then my rule is opposite of X, opposite of Y. So opposite of opposite of -3 is 3, opposite of 1 is -1. And then if I do clockwise 270, that means I'm going to do opposite of Y and X. So I'm going to take the Y, put it in the front, and do its opposite, which is a -1. And I'm going to take the X and put it in the back, so that becomes -3. So we get a -1, a -3. I want you guys to try, well, hold on, let me do the X for the counterclockwise. So remember, these are different. These are reversed. If it's counterclockwise, 90 degrees is right here. The 180 still stays the same. And then 270 is kind of like what 90 was. Okay, so when we go here, counterclockwise 90 degrees, counterclockwise 90 degrees is going to go ahead and be the opposite of Y and X. Opposite of Y and X. So we're going to have -3, +5. When we're doing counterclockwise for 180. And that's a nice thing. With 180, they're not going to tell you clockwise or counterclockwise because there isn't any such thing. There is no such thing as clockwise and counterclockwise with 180. They're just going to say it's rotating 180 degrees. You don't have to worry about asking yourself if it's clockwise or counterclockwise because it's all the same. Opposite of X, opposite of Y. So that's going to become -5, -3. And then our counterclockwise for 270 is the same rule as the clockwise of 90, which was Y opposite of X. So that becomes 3, -5. Okay, I want you guys to go ahead and do points B, C, Y, and Z on your own. All right, let's go ahead and go over this real quickly. I'm not going to rewrite all of this over here. I'm just going to keep it the same. So for problem B, who can tell me what is the new coordinate going to be? Armando? It's going to be a -5, -7. Very good. The y value comes to the front. The x value changes to the opposite and goes to the back. What about for the c value? What is the new coordinate going to be for that one? Yo-chan? Oh, no, for the c value. Let's do c. C value is 90-degree clockwise turn. -8 and +2. Very good. So that's going to be our c prime. Okay, for our 180-degree rotation for B, for point B, Ray, what is that going to be?
-7, +5.
Good. -7, +5 for our 180-degree rotation of point B. What about for point C? What is that going to become, Trang? 2 and +8. Very good. So it just becomes opposites of both of them. All right, for our 270-degree clockwise rotation for point B, what is that going to become? Eoab? Point B's 270 clockwise rotation, what will point B become? Five, 7. Make sure you're paying attention, okay? All right, for point C, what will that become? Let's go with Michael. Michael, what did you get for point C? What does it become? +8 and then -2. Good. All right, so those are our clockwise rotations. Let's take a look at our counterclockwise rotations here. For Y, our counterclockwise rotation of 90 degrees for Y. Sujung, what did you get for that one? -9 and -1. -9 and -1. Remember, the x does not change. It just changes position, but it doesn't change its value. It's -9 and a -1. What about for Z? What is the counterclockwise of 90 degrees going to become for that one? Maya?
The number C?
For Z.
Oh.
Yeah, for counterclockwise 90.
Would that be 12, 8?
Not 8.
18?
18. Yep, 12, 18. Very good. 12, 18. All right, our 180-degree rotation. 180 degrees. Nicholas, what did you get for point Y for 180 degrees? I can't hear you, honey. Do it right now, baby. Very good. 1, -9. Okay. So you're just taking the opposites of both of the values. So -1 becomes a +1, +9 becomes a -9. For Z, Dakota, what did you get for Z?
-18, 12.
Very good. -18, +12. All right. Counterclockwise for 270 degrees. Counterclockwise for point Y. Let's go with Divya. What did you get? 9, +1, right? The Y value comes to the front. The opposite of the X goes on to the back. Okay, and then for our point Z, Bridget? -12, -18. Very good. All right, so you have a worksheet again. We're going to do just those worksheets, but I've cut a lot of it down because I know it's a double unit. I cut a lot of it off or trimmed a lot of it down. It looks like it's a thick packet, but it really isn't. And you'll just be working through that for today. So here's what it looks like. You have 2 questions on reflections. You're reflecting these points up here in blue. or I'm sorry, you're graphing these points in blue just so that you can see what they look like, and then what you come up with for your answers down here is going to be graphed in the red. I've crossed off problems 3 and 4. Problem 5, they wanted you to draw it, and it's just too darkly shaded for you to see it, so I'm just having you tell me what the points would be for point A and point B if they were reflected across the x-axis. So remember, your x-axis is that horizontal, so it's going to be a vertical flip. Okay, then you're doing problems 6 and 7 where you are describing which axis did you reflect across. Okay, then I skip all the way to problem 20 and 21, which are multiple choice. 22, you are only going to be finding the coordinates for point R. You're just finding the new coordinates for point R. And then I've skipped all of the Common Core review. Then we go on to our rotations. For the rotation, I'm just having you do one of the graphing ones. And you, again, graph the original points in blue and the new points in red. For problem 4, you're going to go ahead and you can use the graph to be able to identify if you're going for point R being x, y. We want to know what is the coordinate for that point going to be. If it's an isosceles right triangle, a right isosceles triangle, okay, that means that you have two identical sides and a right angle that's being formed. So you'll plot those 2 points, and you need to figure out where does point R have to be located in order for you to be able to create an isosceles, or two equal lined measures that will connect together to form a triangle that's a right triangle. You'll tell us what the original points for R are going to be, and then you're going to rotate it. You're going to rotate the whole triangle counterclockwise about the origin, and you don't have to tell me what the new coordinates are, but you do have to graph the new coordinates. You have to graph it. Okay, number 5, you're just going to look through here and you're looking at these letters and saying, okay, if I were to rotate it 180 degrees, which letters would still look the exact same? Which ones would still look like their same letter? Okay. Then we've got a persevere problem. We want to know if you were to go ahead and take these triangles and reflect it across the x-axis and then rotate it 180 degrees counterclockwise, what will the coordinates of the final image be? Then you've got a little practice multiple choice question. I got rid of these 2 here. This one, you're just identifying what the translations are, or sorry, what the transformations are for A, B, and C. One of them is a translation, one of them I believe is a reflection, one of them would be an idea of a rotation. Okay, and then here, it had a whole bunch of points. I'm just having you focus on one point, point M. You're going to rotate 90 degrees clockwise, 180 clockwise, 90 degrees counterclockwise, and then your Georgia practice again. Okay, and no, it seems like a lot. I promise you it's really not. It goes pretty quick.
So, do we graph the original thing? Oh, do you want to work with me? I already said no. Everything. You have to, like, what we did yesterday, I think, we just graph the original first and red. Or what? Oh. Oh, No, bro. No, I see it wasn't me, bro. Who did that? Stupid. Alright, guys.
So like when we're graphing this number 2, are we going by 2s like here or by 1?
I would just go by ones.
Does this one, does the coordinates like go by 2?
I would just go by ones. If they don't have them written there, you can go by ones.
It's just shoes. I'm not gonna whine over that.
These French are these numbers also in 2, 4.
By ones. Hey guys, problem number 2. Listen up. Shh. I've had 4 of you come up and ask. If there aren't any coordinates written, like I know problem number 1 had it counting by 2s, but problem number 2 doesn't have anything written. If there's nothing written, just count by ones. It's perfectly fine.